Hello, beautiful people. Welcome to another episode of Meet the Scientists. I'm Chris Jones. I'm talking for COP26.tv. I'm going to be introducing today Dr. Gavin Harper from the University of Birmingham Centre for Strategic Elements and Critical Materials. He's a research fellow on the UKRI's Interdisciplinary Centre for Research into Circular Economy of Technology Metals, also called MET for Tech. So I'm really interested. So welcome, Gavin.
Thank you very much. It's great to be with you today.
So I'm going to get stuck in straight away. I'm a chemist. I'm very interested in hearing about the challenges to do with critical materials and a little bit more about MET for Tech and what that means, and also how that relates back to COP26 and those goals as well. So would you be able to give us a sort of high level summary of what you guys are researching and what you guys are doing at the moment?
Yeah, of course. So we set up the Birmingham Centre for Strategic Elements and Critical Materials several years ago. For people that might be unfamiliar, a critical material is one which is really economically important but also at risk of supply disruption. And I think, talking about supply disruptions, the past couple of years, the general public are much more aware of what can happen when supply chains fail, and whether it's PPE or beer in the pub, petrol at the pump. We've seen all sorts of challenges with supply of different goods and services. But specifically in terms of critical materials, they are materials which impart valuable properties to technology products, and in particular technologies that are going to be really important in the energy transition and for decarbonisation. And because of those unique properties, it's really not very easy to substitute those materials for other materials. And so in the UK we've got a very specific context, because obviously previously our critical materials policy was done as a member of the European Union in concert with others. Brexit has obviously completely changed many things and reshaped trading relationships with partners around the world. And so we were aware that the UK would need to develop its own independent policy around securing access to those critical materials. And the Interdisciplinary Centre for Circular Economy of Technology Metals grew out of another project that was hosted at Birmingham, CREAM, the Critical Elements and Materials Network, and it brings together a range of partners across UK academia to research these problems from lots of different angles.
So could you give an example of a critical material, for example?
Yeah, of course. So if we think about offshore wind, the UK obviously has a fantastic offshore wind resource that we could do much more than we're even doing at the moment to make the best use of. But to do that, we obviously need those offshore wind generators. And because of the nature of building and servicing wind generators offshore, we want to try and make them as reliable as possible. And so one of the points of failure in conventional wind turbine designs is the gearbox, because you have the wind turbine blades spinning very slowly and you have an intermediate gearbox to speed that up to spin a generator more quickly. Now offshore, it's very difficult to service, maintenance and repair things, so ideally we want to build wind turbines that don't have that intermediate generator. So to do that, they use something called a permanent magnet generator, and that's able to extract the electricity from the wind, but with a direct drive, turning much more slowly, less moving parts, less to fail, and so it makes a lot more sense for these enormous turbines that are being built out at sea. But those generators are dependent on a critical material, neodymium iron boron magnets, so-called rare earth magnets, and at the moment the monopoly supply of that magnetic material is that it is mined, it comes from, and it's processed in China, and so obviously that represents a degree of supply vulnerability. So that's one example of a critical material that's going to be absolutely crucial to the energy transition.
And I guess you've got things like the materials needed to build solar panels as well. Is that something that you would consider a critical material as well?
Yeah, so for sure. I mean, I think lots of solar panels now are sort of polycrystalline. They're based on silicon sand. Not quite so critical. But then, if we've got thin film solar devices, they use more exotic combinations of materials. I think another thing that's particularly high up policymakers' agenda at the moment is the materials that are needed to produce lithium-ion batteries. So, the electrification of transport, moving to electric vehicles is going to be highly dependent on, being able to store energy in a compact form in a mobile way. Lithium-ion batteries are the ideal technology for doing that. At the moment, there's materials, lithium, nickel, cobalt. These are all materials of concern that the UK doesn't have great indigenous resources of. I mean, there's some exploration of lithium in Cornwall. You might have heard of Cornish and British lithium. They're doing some work there to try and look at, can we produce some lithium domestically. But for example, cobalt, the majority of cobalt comes from the Democratic Republic of Congo. There are all sorts of challenges with sourcing materials from there, in terms of social, environmental, human rights, ethics, etc. And so it's really thinking about what are the approaches that we can use to mitigate against some of the challenges posed by materials criticality.
So I guess you mentioned some lithium-ion batteries, which you might find also in mobile phones. Is that correct?
Yeah, for sure. And also another thing is thinking about sort of stationary energy storage. So you might have seen the enormous battery in Australia, the Hornsdale Power Reserve. That's helping them to balance intermittency, which allows a greater penetration of renewables onto the grid, which is a great thing for decarbonisation. It's helping to stabilise Australia's energy network. So really critical piece of infrastructure. And you can imagine in the UK that if we want to integrate ever greater proportions of renewable energy onto the grid, we're going to need some stationary energy storage as well. So other applications there of lithium-ion batteries. And I think in terms of scale and quantity, if you think sort of mobile phones are ubiquitous, there are more mobile phones than people, because people often have sort of 2 or 3 or a business phone or work phone, but the batteries in those are very small. If you think about the Hornsdale Power Reserve, it's an enormous battery that uses an enormous volume of material, but at the moment there's only one of that scale, and there are only sort of a handful of smaller ones dotted around the place. But vehicle electrification is one of the real challenges, because it's that sort of middle-sized battery where it's really quite big, but at the same time you've got that volume and that scale associated with producing lots of them, as most families in the developed world have got 1 or 2 cars.
And obviously, as we that there is a drive towards moving away from fossil fuel based automotive services such as cars and buses, we're going to need significantly more of these critical materials you mentioned.
Yeah, for sure. And I think, it's the transformation of an entire industry. I mean, if you think about the UK automotive landscape, we've got enormous expertise in the UK around building really good internal combustion engines, but that's a technology that obviously is going to start to decline as we transition over to electric vehicles. And so you think about the transformation of that entire industrial sector, and all the different sort of job skills transition that's going to be needed to sort of move people onto these new technologies. But underpinning that green industrial revolution, we need access to the materials that are going to enable that manufacturing industry. And other countries, and namely China, have been much more proactive in securing access to those critical materials that are going to underpin their energy transition. And I think for us it's about thinking about where can we source these materials from. One option is looking at the end of life. So just circling back to, we were talking about offshore wind, we were talking about neodymium for rare earth. We're not going to be opening neodymium mines in the UK, it's not something that we have here, but we could look at the idea of sort of urban mining. So this idea of taking wastes that have come from old electronic products and thinking about how can we extract that valuable material and turn it into something that can be used in future wind turbine generators, electric car motors, efficient central heating pumps, etc. And the Magnetic Materials Group at University of Birmingham have been looking into this, so they were part of a project, ReproMag, the new project, SUSMag Pro, that they've got is looking at the sustainable production of neodymium rare earth magnets from all of these scrap materials.
That's a very, very interesting thing for me. I personally work in upcycling and recycling. That's so I would love to hear a little bit more about that. So in terms, because I've been looking at a lot of research overseas. So in places like India, where a lot of our electronic waste goes currently, they're sort of using fairly crude methodologies to get copper out of things like that, and they end up burning and sort of standing in the smoke, and quite frankly, causing severe personal harm to themselves to get a basic living wage. I guess so. Are these projects kind of new, or have they had some level of success?
So, I mean, to give you an example of another project that we've got, the Faraday Institution, which is this sort of UK-wide body for looking at research into electric vehicle batteries to support the UK's transition to an EV industry, has got a project that's led out of the University of Birmingham, the ReLib project, recycling and reuse of lithium-ion batteries, where we're trying to look at what are the most effective technologies that we can use for recycling lithium-ion batteries. And there is of course concern that some of these vehicles may be sold into other markets, and they end up in markets that haven't necessarily got the technology or capacity to process them at the end of life. But we're really looking at how can we retain the critical materials that are in electric vehicle batteries within our economy. How can we do that as efficiently as possible? Because even though recycling, waste management, end of life vehicles are to some degree well regulated activities, and there are controls around pollution, emissions, etc. What we want to really look at is how can we recover the greatest proportion of materials from things like electric vehicle batteries at the end of life. How can we use more sophisticated methods that enable us to retain the materials in their highest value form, so that we're not downcycling them all the time, and turn them into new products.